All right, so today we're going to be talking about 1.8. 1.8 is all about solving inequalities. And inequalities, they're very similar to equalities with the equal sign. However, they can be in the form of these symbols for your relations. There's the less than symbol. There is your less than or equal to symbol. There's your your greater than symbol. And then there's your greater than or equal to symbol. These are your main symbols. Now, a lot of students have the confusion of what these symbols represent. So intuitively, with the less than and the greater than symbol, we all have an idea. If the number is smaller, then it satisfies for less than. If the number is bigger, then it satisfies for greater than. So for example, 5 is less than 8. This is a true statement. True. 8 is bigger than 5, or 5 is less than 8. Now, what you guys got to understand, though, is that that's also the same as saying 5 is less than or equal to 8. So these statements in particular uses the word or. This is less than or equal to. The key word is or. When I say the word or in mathematics, that means it could be less than, it could be equal to, or it could be both. If it satisfies any of those three conditions, then the statement is true. So in this case, although 5 is not equal to 8, 5 is less than 8, so I can say that 5 is less than or equal to 8 is a true statement. Be very cautious at understanding these statements. So, in general, all the symbol less than or equal to, and then the other symbol greater than or equal to, are just the same symbols in different directions. If you were to swap around the left side of the inequality with the right, then you should have the same statement. So if I were to instead put 8 is greater than 5, that's a true statement, or 8 is greater than or equal to 5. If I were to swap the number and swap the direction. Now, previously we worked with equations, which has the equal sign. This right here, there is no, in the equal sign, it carries both directions equally, or I use the word equally in it, but both directions hold the same value. However, with the less than or greater than, your direction does matter. So, let's move on to a couple of things. We need to know how to solve, or first, before we even solve it, we need to understand it itself. So, if I were to give you this equation, 4x plus 7, and I said equation, so we have an equal sign. If you were to eventually solve this out and everything, you get x equals 3. Great. How does your solution look for that? Well, if I were to draw a number line where this is 0 and this is 3, I have a single point at 3. This represents my solution is only the number 3. Correct? So you have one solution for a linear equation. You can also have no solution or infinite. We talked about that already. However, with the inequality, it doesn't behave that way. If I were to solve this out right here, this inequality, 4x plus 7, let's say we have less than or equal to 19. And then eventually, if we solve it out, we get the exact same thing, but x is going to be less than or equal to 3. So what does this mean? Well, notice that we have less than or equal to. So we also have to include 3 because it is equal to 3. Now we also have to count the values that are also less than 3. So if you look at your number line, that's to the left side. This is our solution over here. Now, sometimes, depending on the color marker people will use when they're doing these problems, they can draw the line on top of the number line itself. As long as you can distinguish that is your solution. So it's going from 3 and it's going all the way to the left. It's counting every single number. Now, for something similar to the test, you might see a problem like, hey, how do I write this in set interval notation? vol notation. Well, this is actually very easy. So if we were to write it in, I'm combining words together, I apologize. Set builder notation. Set builder notation. It would be the same as x belongs to, we want the real numbers in this case, because we want the decimals as well. We want the fractions. We want all of that. X is a real number such that x is less than or equal to 3. That's an easy one. Boom. We're pretty much using the inequality for our condition. Now, to write it in interval notation, well, from the farthest left side of your number line, you're counting all of the negative values. So you start at negative infinity. However, you're going to go all the way to the right until you stop at 3. Now, do we want to include 3 or not? In our case, we do want to include 3. So boom. So we're going to use brackets. Brackets mean include. Now, if you notice, this means not include. You cannot include infinity or negative infinity just because it's not a real number. So if you notice that, hey, if I have a less than or equal to symbol, that means I will include it. Which means that if I were to have, this right here is set, this is called interval notation. Vol notation. Right here. If I were to have, let's say, x is less than 5, if I were to draw a number line here, I would go to where 5 is. Let's put 0 so we have an idea. Then I would actually draw a circle at 5. But then it's less than, so I'm counting every number to the left of it. However, I don't want the number 5, so I do not fill in that circle. This circle stays as a whole. It's missing that value. It's missing 5. Now, I do want to count 4.99, 4.5, 4.3, 0, negative 5. I want to count all those numbers so I can draw a line over there. And then if you were to write this in, let's go with interval notation, you would do negative infinity all the way to 5. But instead of brackets, you would use parentheses. So if you see it without the equal sign at all, we're going to be using parentheses. If, like above, I have the less than or equal to symbol or greater than or equal to symbol, this means you're going to be using brackets. That's the idea. Okay? So we cleared that confusion. Now there's a few properties I do want you to note. Some of these properties you can figure out on your own. However, these properties, I think they're very important. So the first property we're going to talk about, inequalities, properties. Inequalities. So the first property we'll talk about is, let's see, just some obvious ones. I want to do the addition one. So let's say we have A is less than B as an inequality, and let's do C is less than D. Actually, this is more clear if I write it this way. And C is less than D. Well, if you notice, these are both going in the same direction. A is less than B, C is less than D, which means that, hey, I can actually add these two inequalities together. I can turn this into I can turn this to as A plus C is less than or equal to B plus D. And the reason why I'm able to do that is because D is less than or is bigger than or equal to C, and B is greater than or equal to A. Both of them are greater than or equal to than the left side. So this does hold. This guy is less than this guy is less than this guy. So if I add these two, they should be less than these two added. Now be careful, I didn't say that worked for multiplication. There's a little rule that we have to work for multiplication. So here's an example that you guys can easily see. Let's say 5 is less than or equal to 10, and let's say 3 is less than or equal to 12. Well, if I combine these two, that's saying 5 plus 3 better be less than or equal to 10 plus 12, and that's clear. So now we got to deal with multiplication. Multiplication plays a bit differently than you would expect. So let's take an example. 8 is less than 10. Let's take this example for. Let's take this as an example. This is a true statement. 8 is less than 10. Good. Multiplication. Let's just stop that. Now, if I add a value to it, let's say 8 plus 3, and if I add 3 to both sides, this better holds, which this is 11 less than, it's a plus sign. This is plus 3, I'm sorry, 13. This holds. Great. But when we talk about multiplication, 8 is less than 10. And I multiply both sides by, let's take -1. Let's say I were to multiply both sides by -1. Then I get -8 is less than -10. Wait a minute. If I draw my number line, -8 is over here, -10 is over here. So it's saying -8 is less than -10, but -8 is on the right side, so it should be bigger than -10. So what went wrong? This is a big issue. What went wrong here? I multiplied to both sides, things worked out. If I had an equal sign, things work out. If I were to say x is equal to 8 or 8 is equal to 8 and I multiply both sides by negative, it holds. But if I do it with an inequality, it didn't play right. So what went wrong? So in actuality, when you multiply or divide, so this is a remark that you guys need to write down. This is a remark. When multiply or divide inequality, quality, always change direction. You need to change the direction of inequality. This is something that actually happens all the time. And it even happens with equalities when you have an equation. It's just that the problem is with an equal sign, even if I reverse the direction of an equal sign, it stays as an equal sign. It doesn't really matter. It's symmetrical. However, with inequalities, you do need to change direction. It does matter. So, in the case where I said 8 is less than 10, and I multiplied -1 to each side, I need to change the direction if I do this. This guy changes direction. Now it should hold. So I have -8 is greater than -10. And this does check out. So yep, it works out now. That's something very important. You will need to know that. And then the last thing that I want to talk about for our property, last property, is the transitive. I think this is just very important in general. The transitive property, if you know what it is, it just means that, hey, if you have an inequality, A is less than or equal to B, and you have C is less than or equal to D, then, wait a minute. But if you have the, oops, I apologize. This should be B is less than or equal to D. Well, this carries over then. That's all it's saying. It carries over. That means A has to be less than or equal to D. That is the transitive property. At the end of the day, if one guy is less than or equal to the next guy, then that same original guy has to be less than or equal to the last guy. That's all it's saying. So it's not like a crazy story or anything like that. That's just the last property I want to get to. Now, let's solve some inequalities. Solving inequalities practice. Let's solve some inequalities. When you solve inequalities, remember, compared to equations or linear equations, you can have more than one solution. In fact, you're going to have infinite amount of solutions. It's just you need to know where the interval of your solution is located. That is the important part. So let's take the example. 3x is less than 9x plus 4. Now, with the inequality, you treat it the same way as you would treat it as a normal equality. The only difference that you will be working with is your solution, and if you divide or multiply by a negative, you have to swap directions. Those are the main differences. So in this case, right here, when we solve an equation, a linear equation, we have to move all the x's to one side. They are not all to one side. So let's subtract a 9x to both sides. And I subtract a 9x. I didn't divide or multiply. I subtracted. So I am not changing the direction. And if I do this, I get negative 6x is less than, remember the symbol stays over it, it's still the same symbol, plus 4. Good. Now, I have to actually solve for x. I moved all my terms already. Now I got to solve for x. Well, to get rid of the negative 6, I've already moved, so I'm not adding or subtracting. I'm dividing by negative 6. Now, remember, I divided by a negative 6, a negative number. If you divide by a negative number or multiply, automatically you will have to change your direction. So let's go ahead and change the direction of our symbol. Boom. It changed direction. So we have x is greater than negative 4 over 6, which is the exact same thing as saying x is greater than negative 2/3 if you simplified it out. Boom. How do you draw this on a number line? This is just a visual. I recommend drawing a visual before you do your solutions. So this is what we have. However, I will require you guys to write your solution in interval notation or set builder notation. So before you even do that, I'd recommend you draw your graph, your one-dimensional line, your number line. Boom. And then you have negative 2/3 over here. You have 0. But you do not want to include negative 2/3. You do not want to include negative 2/3. So draw a circle here. Use a different color. Draw an open circle, meaning that you do not want to include. You didn't fill it in. Then x is greater than, so any number bigger than that. Well, if I'm getting a number bigger, that's to the right side. So I want every number to the right side. So now, if I were to write it in set builder notation, set builder, you would have x belongs to real numbers such that x is greater than negative 2/3. So that's easy. That's easy. Now, if you were to write this in interval notation, interval, as your solution, you would say, hey, I start at negative 2/3, but I did not include it, so I use a parentheses. And then I went all the way to infinity. Now, you cannot include the number infinity. It is not a number, so you can't include it, so you have to use parentheses as well. That's your interval notation. Okay, so we're able to solve linear inequalities. Great. And we were able to show you I was able to show you guys the example where you had to divide or multiply by a negative. Now we get into some fun stuff. Well, what if you had, example 2, what if you had multiple inequalities and an inequality in between an inequality? What if you had something like that? Well, there should be no difference in how you treat this equation. The only thing you would have to worry about is that when you apply something to one side of the equation, you got to do it to all sides of the inequality. So, are your x's isolated? No, you got to get rid of the -2. So you got to add 2 to both sides. Well, what do I mean by both sides this time? There's more than just 2 sides. There's 3 sides now, so I have to add 2 here and add 2 here. So the only difference is that, hey, instead of doing a left and a right, I have a left, middle, right. 3 sides. And then I do that. I have 6 is less than or equal to 3x, which is less than or equal, or less than, 15. Then you got to divide by 3. Divide both sides by 3. Now, 3 is a positive number. I'm not dividing by a negative, so I do not have to change the direction. If you were to change the direction in this case, you would change both inequalities direction. You would change both if I were dividing by -3. However, I'm dividing by positive, so I don't have to worry about that. And you get 2 is less than or equal to x, which is less than 5. And then how do you write this? So if we were to just draw your number line, 2 is over here, 5 is over here, 0 somewhere over here. I like to just draw 0 just because. And it says x is in between these two values. So x has to be from 5 and 2. Now we include the number 2, but we do not include the number 5. And then we're just going to go everything in between there. Boom. So this means that in set builder, put set builder, you're going to have x as an element of reals such that you can just write the exact inequality. Nothing complicated. Oop, can't write that side. Boom. And then how do you write it? Interval notation. Well, I started with the number 2 over here. 2, and I ended at 5, but I want to include 2, so I use brackets, and I don't want to include 5, so I use parentheses. Boom. Moving on. Now we get into, hey, we finished linear, so now we go into quadratics. Quadratics is a little bit tricky. So, quadratics. Quadratic inequality. So this time I have x squared is less than or equal to 5x plus 6. All right. Well, quadratic says that you want to have it all equal to 0 just to make things nice, unless you're completing the square. In this case, even if you're completing the square, you need to move all the x's to one side. So let me subtract 5x. Let me subtract 6 to both sides. Now there's no like terms at all, so I have x squared minus 5x minus 6 is less than or equal to 0. Boom. I did not divide by a negative. I subtracted, but I did not divide by a negative. Boom. Now, you guys should be able to recognize this kind of problem already. So in your head, you should already tell yourself factor. If you were to factor this out, this becomes x minus 6, x plus 1, and then your, oops, this is supposed to be, did I write this problem wrong? That's fine. Minus, yep, we're good. It's less than or equal to 0. Now, once you have that, you know that this means x equals 6, x equals negative 1. I'll put a question mark though. What does that mean? So if I plug those values in, they are equal to 0 because they're going to make each term 0. 6 minus 6 is 0. Negative 1 plus 1 is 0. Now, do we want the number 0? Well, we're using less than or equal to 0, so we do want them equal to 0. So go ahead, draw your number line. So let's say we have, negative 1 is over here, 0. Let's put 6 all the way over here. We do want those numbers, so go ahead and fill those in. If you were to draw a circle, color them in. Boom. Now, the problem with quadratics is that you don't know how it behaves. You don't know if we want the number negative 5, if we want the number 0, if we want the number 2, if we want the number 10. You do not know that. So the great side about inequality, though, is that I only need a test. So you need to test values. You need to test values in this region. You need to test values in this region, and you needed to test values in your last region. There's only 3 regions you really need to test. If you can choose a number in those regions and test them for x and see if they're less than or equal to 0, then you're good to go. So let's test some values. And this will become, you guys will become more used to this, especially if you go into calculus with critical points. So let's do a test values. So the first value I need to test is a value that is less than negative 1, because I want to test this portion, this region. I want to see if the region is true or false for the inequality. So we have to choose a number less than negative 1. Let's choose negative 2. If I were to choose negative 2, I would have negative 2 minus 6 times negative 2 plus 1 is less than or equal to 0. Or, yeah, less than or equal to 0. Is this statement true? Well, let's solve it out. What is negative 2 minus 6? Negative 2 minus 6 is negative 8 times negative 2 plus 1, that's negative 1, Is this true? Negative 8 times negative 1. Is that less than 0? Well, what's a negative times a negative? That should give you a positive. So this is not true. So we do not want that. We do not want the first region in our number line, the blue region. We do not want this. Boom. Now we got to check the middle region. Well, let's choose an easy number in the middle. Once you choose a number from that region, you're done for that region, thankfully. You don't have to check every number possible. So I'm going to choose an easy number. Let's choose 0. 0 generally makes life easy. So let's check 0 now. Now, I have to plug it back into this original equation. You can put an original over here. It doesn't really matter. So 0 minus 6, 0 plus 1, less than or equal to 0. If I were to plug these in, I get negative 6 times 1. It's less than 0. What's negative times a positive? That's negative 6, less than 0. Is this statement true? This is true. So we do want that. So go ahead and already color that piece in. We do want that region. And then the last region, let's try on the right side for the orange. Let's try the value 10. If I were to plug in 10, I get 10 minus 6 times 10 plus 1 less than or equal to 0. We get 4 times 11. This is 44 less than or equal to 0. This is not true. So we only have one region that is true. Boom. So you do need to test all regions because sometimes you will have more than one region that the inequality holds. In this case, it works out for only one. So this is our solution right here. And if we write that in interval notation, or let's first write set builder notation. If we were to write that in set builder notation, that's x belongs to reals such that, well, x is in between negative 1 and 6. Now, do we want to include those numbers? Yes. So put an equal sign on those. If you notice, we filled in the circles there, so we did include those. If you didn't want to include the numbers, you would take away the equal sign. That's set builder. Now let's do interval notation. If you were to do interval notation, you start at negative 1 and stop at 6. Negative 1 to 6. And you want to include both numbers, so you use brackets. Boom. This is set builder. This is interval. Get comfortable writing in these two forms. All right, so this is probably the trickiest one you'll see with inequalities just because you have to test values in. Now, one that I do prioritize a lot in tests and such, so that means you do need to know how to do this, would be how to solve absolutes. There is rational inequality. However, I leave it as an exercise or for your own reading to read through it. It's the same idea as solving quadratics. Now, I want to know how to solve absolutes. These are very important. So, absolute. If we remember anything about absolute, it turns everything inside the absolute value positive. So, let's say we have x minus 5. How the heck do we solve this? So I'm going to tell you as a little remark, always isolate absolute. Always isolate your absolute value symbol. Now, what that means is that inside, it doesn't really matter. However, outside should be nothing there besides the absolute. If there's a 2 in front of the absolute, you got to get rid of that. If there's a 5 in front of the absolute, you got to get rid of that. That's the idea. So in this case, it's already isolated, so you don't have to worry. Now, remember, when you're solving absolute values, there's always the positive. You only accept positive answer. However, there could have been a case where your answer originally was negative, but it turned into positive. So when we're solving this inequality, we have to account for that. If I were to do, let's say x is less than or 6. Well, x could equal, it could be 6. X could be, I'm sorry, let me fix this. Let's say x equals 6. Let's use the equal sign to make it more clear. X could easily be 6, but it could also be -6. So do you see how I have a positive and a negative for my values? Well, we need to know how to actually get our two answers, two solutions. So in this case, what we're going to be doing is to account for your positive and negatives, we're going to break our inequality into two pieces once we isolate it. So the first inequality is going to be the positive. So if I were to just get this original inequality, take away the absolute symbol, I should have just a positive answer too. In our case, if I had x equals 6, I'm taking away the absolute symbol and just putting 6 equals 6. Or, sorry, I'm just taking away the absolute and just putting x equals 6. Good. That's the first part. Now, the second part, we have to account for the negative. So if I were to take the absolute value, well, I have to also let the answer be -6. So what I'm going to do is, I'm going to get x minus 5 is less than -1 times 2. Now you guys should see an issue already. So we turn the right side negative. That's what we're doing in absolute. We have to account for the positive and the negative. And to account for the negative, I have to multiply it by -1 for an inequality. So if you guys recall, if you multiply by a negative, that means you literally have to switch directions. Boom. You have to switch directions. Must switch direction. Must switch directions. Because you multiplied by a negative. Boom. Now you can solve this out like a normal inequality. Well, I have to add phi to both sides. Oops. Add phi to both sides. I get x is less than 7. And then over here, I swap the direction. Now I have to add phi to both sides. I get x is greater than 3. And our original one, we use less than. This was a less than symbol. We use a less than symbol originally. And over here, I have a less than, but I have a greater than now. So you'll notice that that does happen sometimes. So when, in this case right here, if I were to draw it out, my number line, let's say 3 is over here, 0 somewhere over here, 7 is over here. Now you don't need to draw 0. I just do it. So 0, I count 3, 7, but however, I do not include those numbers because I do not have an equal sign. Now x is greater than 3, but x is also less than 7. So this is not really stated in there, but your solution is x is less than 7 and x is greater than 3. So it has to satisfy both conditions. Your solution have to not only be less than 7, but also has to be greater than 3. And the only possible piece that works is in between 3 and 7. So if I were to write my inequality, or in let's say in set builder, I would have x belongs to reals such that x is in between 7 and 3. You could state it like that. That's when you get the and symbol. Now, how do I know x is in between 7 or 3? Well, if you draw the picture, you can see that clearly, but sometimes it's not going to be in between. And I'll talk about it after I show you the exception. So now we go into another problem that I really like. Let's get blue. Let's do this example. Where's it at? -2 plus 3x plus 2 is greater than or equal to 4. So this time, instead of using the less than symbol right here, I'm using greater than or equal to, and it will make a difference. It will make a huge difference, actually, which direction you're using. So if I were to solve this, First, I have to isolate my absolute value symbol. It is not isolated, so I gotta get rid of this minus 2. And I have to move it. If I get rid of it, I get 3x plus 2 is greater than or equal to 6. Boom. So now it's isolated. Great. Now I can actually break it into the positive and the negative solution. So the positive solution is the exact same thing without the absolute symbol. It's that easy. Should not be hard. Now for the negative, I have to do the exact same thing. However, my direction will change because I multiplied this by -1. And I'm changing it here. That way I don't make a mistake. I'm changing it early on as quick as possible. So you notice that these symbols. Now you notice that I showed you earlier that the symbols right here, less than, or they should be different direction for both positive and negative. You should have it in different directions. So if they're both in the same direction, then just double check just to be sure. All right, great. Now I can solve it out. Let's solve it out. So we have 3x, I can subtract 2 to both sides, is greater than or equal to 4. And if I divide by 3, this is the positive 3, I have x is greater than or equal to 4/3. All right, 4/3. And if I do the other one, I get 3x is less than or equal to -6. Divide both sides by 3. Now, even though I have a negative number dividing by a positive, because I divide by a positive and not a negative, I do not change the direction. So it stays as the same symbol, -2. I change the direction early on when I multiply it by -1 over here, but I do not need to change it when I divide by 3. So now I have this. Great. Let's graph this on the number line, and you will see a weird behavior. This is the difference between less than or greater than, or less than or equal to and greater than or equal to. Boom. So if I were to graph this out, 0's over here, 4/3 somewhere around here. I don't know exactly. I don't really care. The -2 is over here. Now, x is in particular greater than or equal to 4/3. So I'm going to have a circle. I color it in because I want to include that, but greater than is on this side. All right, good. Now, if I go to the second inequality over here, my second solution, I have x is less than or equal to -2. So I do include that, but is less than, so I'm going to the left. Well, do you see how they're not connected? So in this case, we have x is greater than or equal to 4/3, or x is less than or equal to -2. They're both our solution, but because they're not connected or anything, we're using the or statement. So now if I were to write this in set builder notation, you would just write x belongs to reals such that x is bigger than or equal to 4/3, nothing changed, or, I mean, you wouldn't capitalize the word or, so lowercase, or x is less than or equal to -2. So this is your set builder notation. How do you write this in interval notation? Because if you notice, they're not connected. Let's recall back in chapter 1. So first, let's work with this piece of interval. We start at -infinity and end at -2. Great. We want to include -2. We can't include infinity. Good. Let's work on the right side now. Well, I started at 4/3, but I stopped at pause infinity. I can't include infinity, but I can include 4/3. I need to combine this somehow. Well, the word or is the same word or the same usage as the word union in mathematics, which the symbol for union is the U symbol, the big cap. So this is a way we turn two collection of objects into one giant collection of objects. We're able to combine our intervals together. So you'll notice that if I have the statement or if I have the statement or if I'm using greater than or equal to symbol on an absolute, my number line will split. I'll have two different intervals. I'm still combining the intervals, but you'll see this behavior. If I use a less than or a less than or equal to symbol, like up here, what will happen is that, hey, the x values will be in between your values rather than being split off like over here. So you do need to do that. And then the last exercise I just want you guys to try out is exercise. You guys can try for yourself. It's -4, 2x plus 6 less than or equal to 8. It's the last exercise. Give it a shot. Now you'll notice that this is -4 times your absolute. So you gotta get rid of that -4. And it's multiplying that value. So how do you get rid of that? I want you guys to think about this problem, see what you guys get. You'll notice that this is another weird behavior because even though this is a less than or equal to symbol, something happens. Something will happen. All right, but that ends it up for 1.8. And if you want to read the other pieces, you can. However, my expectations are mainly how to solve these absolute value inequalities and understanding the ideas of critical points. This is really going to play a big role when you get into calculus. So you do need to know how to do these plug-in values for each, I guess, region of your interval to see if they are true or false. All right, that ends it off. Well, take care. Bye.